maxima and minima for a function of two variables.
Hello future engineers and my dear students, welcome back to Mudassir Academy. I am Mudassir Sheikh, and as you know, we have been learning the Engineering Mathematics 1 Module 2 for VTU step by step. In the previous videos, we solved some very important exam questions on partial differentiation. We practiced some questions on the chain rule, and also in the previous video, we have solved some very important questions on Jacobians. Today, we are going to learn yet another extremely important and a very scoring concept, that is maxima and minima for a function of two variables. And as always, my duty is to make things as simple as possible for you, and I promise that by the end of this session, you will be able to solve any problem in maxima and minima for a function of two variables perfectly. So now you please keep your pen and notebooks ready and practice along with me. Most important, don't skip any part of the video. Every step matters in understanding and solving the problems correctly. And also it's your support that encourages me and gives me that stamina to make more useful videos like this for you, even though I'm facing some critical health challenges. So please like the video, comment on what further topics you like me to cover later, and share these videos with your friends and classmates and do the good work. And in the end, please don't forget to subscribe. See, the concept of finding the maxima and minima for functions of two variables is a procedure. So, I will explain the procedure in a very simple way as possible here. So, please listen to me carefully. So, let us have a function, say f of x comma y, where x and y are the two variables. For this function f, we need to find the maxima and minima, that is the maximum and minimum values. The first step what we are going to do here is that we are going to find fx and fy. What? We are going to find first fx and fy. Right here, fx and fy. So, what are these fx and fy? See, we have learned in the previous videos also. Please refer them, okay, in the playlist. When we have a function u and we are partially differentiating with respect to x, we write it as dou u by dou x, also represented as ux. Also, when you partially differentiate with respect to y, we write it as dou u by dou y or ui. Similarly, the function n is f here. So, the partial derivative of f with respect to x is fx and with respect to y is fy. That is it, as simple as that. Now, the next step what we do is, after finding fx and fy, we assign or we equate fx equals to 0, also fy equal to 0. So, we have two equations here. Why this equation is important? Because from these equations, we are going to solve both the equations and find some points or ordered pairs. Okay, we are going to solve these two equations, and from this, we are going to find some points or pairs. Okay, we equate it to 0 and we find some points x1, y1, say x2, y2, say x3, y3, and so on. Okay. How much possible you find? These all the pairs or the points are called as what? Stationary points. What points? Stationary points, which are very important here. Okay, from this all the points found, some a point will have a maximum value, a point will have a minimum value, and some are of no use, called saddle points. Okay, now when you find the stationary points, we use some conditions. This condition is very important. We use some conditions. Applying the condition to this, okay, a point will be maximum, a point will be minimum, or a point will be saddle. That is neither maximum or minimum. No use. Okay. See, maximum point is where a function reaches the maximum value, like a top of a hill. Minimum point is where the function reaches the most lowest to the minimum value. That is the bottom of the value example. And a point where the slope in all direction becomes flat is called stationary points. Okay, but the stationary points are only important for when you find the stationary points. Out of these stationary points, some will represent maxima or minimum, or another maximum minimum saddle. We don't use it in a solution. That's it. Okay, now let's see how the conditions works. To apply the condition, first we find A. A is equal to f double x. That is, from f we find fx, again double differentiate partially. fx, we get a is equal to f double x. This f x y, that is what we partially differentiate with respect to x, that again we need to partially differentiate with respect to what? Y. It is b is fx y. And lastly c is equal to f double y. So what is fy? Again double differentiate partially with respect to y, we get f double y. So we need to find a as f double s, remember b as fxy and c as f double y. Okay. Some textbooks denote it as RST also, but for more simplicity I am taking here as ABC. Fine. Now with this and the stationary points, we have the conditions. What are the conditions? Very, very important conditions. The conditions are if AC minus B square greater than 0, very important condition, and if A lesser than 0, that point is called as what point? We call it maximum. What's the condition? AC minus B square greater than 0, and if A is lesser than 0, understand it. The next is if AC minus B square again greater than 0, and if A is greater than 0, that point is what point? Minimum point. And if AC minus B square is lesser than 0, is called as what? Saddle. We call it saddle. That means saddle means what? We don't use it in solving the problem. That's it. Simple. I hope you understood this now. So one more time. First, the question is given. From the given question f, we first find, you partially differentiate f x, f y, and equal to 0. Solving both the equation, we get some pairs of points x1, y1, x2, y2, so on. It is called stationary points. Now the condition for the condition, we find A is f double x, B is x y, partial differentiate x with respect to y, f x with respect to y, and finally f double y means partial differentiate f5 with again with y, f double y. Then the condition is if AC minus B square greater than 0, see compulsory, it should be what? Greater than 0, compulsory greater than 0. And if A is lesser than 0, that point is what point? Maximum point. Remember, lend a years here. AC minus B square greater than 0, A lesser than 0, maximum. A lesser than 0, maximum. And also greater. And if A greater than 0, then what? Minimum. See, lesser means maximum. If the value of A, this A of double S is lesser means is maximum, greater means minimum, and is lesser than 0, then saddle point. The saddle point, we don't use it. We don't use it in the problems. That's all. This is simple method how to find. So this I'll explain while solving the problems. I'll explain in a very, very simple way. Okay, everything I'll put a table and show you how it was. Okay, so now let's start solving the problems to make it very, very simple for you. So please stay to the end and watch everything carefully so that you don't lose even a single marks. So let's understand the concept of maxima and minima by solving these problems here. So it states find the extreme values of the function f of x5 is equal to x cube plus y cube minus 3x minus 12y plus 20. Extreme means the maximum and the minimum values. Okay. Now let's set a question here. We have f x comma y is equal to x cube plus y cube minus 3x minus 12y plus 20. So as we discussed sometime earlier, the finding the extreme values of the maximum and minima is a simple process. So first what you do, we find fx and fy, that is we partially differentiate this with x, we get fx will be equal to what? X cube is, see here we are partially differentiating only with respect to what? X. So fx will be 3x square, y cube, there is no x term, 0, minus 3x, differentiation of 3x, x is 1, so minus 3, done. again Fy is equal to, here we are partially differentiating with respect to what? Y. Only the y terms, x cube is 0, no y term, only y term is here. So, it will be 3y square 3x 0 minus differentiation of y is 1. So, minus 12 into y. So, we have 3y square minus 12. Okay. So, we have fx and we have fy. Fine. Now, the next thing is we assign fx is equal to 0 and fy is equal to 0 to find the stationary points. Let us do it here. So, fx is equal to 0, okay, implies 3x square minus 3 equals to 0 and fy equal to 0 implies 3y square minus 12 is equal to 0. Let's solve these equations now to find ordered pairs. We have 3 into x square minus 1 is equal to 0, that implies x square minus 1 is equal to 0. So, x is equal to plus and minus 1. Fine. Similarly, here also 3 outside y square minus 4 is equal to 0, 3 and 0 cancels. We have y square is equal to 4, it means y is equal to plus or minus 2. So, this x is equal to plus or minus 1 means the points are 1 and minus 1 and this is 2 and minus 2. So, from this points easily we can make some ordered pairs because both are separate values. Okay, we can make some ordered pairs to get the stationary points here. So, the stationary points are, see, 1, 2 are right here, 1, 2, again 1 and minus 2, 1 and minus 2, again minus 1 and 2, minus 1 and 2, again minus 1 and minus 2. So, these are all the maximum order pairs combinations I can obtain and these are called as what? Stationary points. Okay. So, we have found all the stationary points here. Next, what is the procedure? We need to find the conditions. To find a condition, we need to find the values of A, B and C. So, what is A here? So, A is f double x, that is, see fx underlined here, 3x square minus 6. Again, partially differentiate the same thing with respect to x. 3 is 0 constant, differentiation of x square is 2x, 3 into 2x is 6. B equals to f of xy. That means partial differentiation of x, that is f of x with respect to y. What is f xy means? Fx what we obtained here with respect to y partially. There is no y terms here. So, 0. And finally, C is equal to f double y. Fy 3y square. Again, differentiate partially with respect to y. Differentiation of 3y square is 6y. Y square is 12, 2 to 3 6. So, we have 6y and 0. So, we found ABC now. The next thing is to make the solution more and more simple. I will explain it in the form of table here. We will put all the stationary points and put all this ABC and check the conditions like AC minus B square greater than 0 and A lesser than 0, AC minus B square greater than 0, A greater than 0 and AC minus B square lesser than 0. What happens? We will check this. I will show you now. Let us draw the table first and see how easy it becomes. So, we have the table here. So, let us write these stationary points. One is 1 comma 2, other is 1 comma minus 2, then we have minus 1 comma 2 and lastly, sorry, this is minus 1 comma minus 2. Fine, correct? Now, write all this A, B, C for the conditions. We have A is equal to 6x, B is equal to 0, fine, and C is equal to 6y. Now, what is the condition? We have discussed the condition was AC minus B square greater than 0, compulsory. Okay. So, we have here AC minus B square greater than 0 is the condition which we need to follow to find the maximum and minimum values. Fine. Now, see 1, 2, these are all various stationary points. X is 1, y is 2, x is 1, y is 1, so on. Let us put in ABC here. What is A? 6 into 1, 6, 0, 6 2s are 12. So, see AC minus B square, 6 12s are 72 minus 0. So, we have 72. Fine. Next, again 6 into 1, 6, 0 and 6 minus 12. So, we have minus 72, correct. Next, again 6 into 1, minus 1, sorry, 6 to minus 1 is minus 6, these are 0 and 12. So, minus 6 into 12 is minus 72. And finally, 6 into minus 1, 6x minus 6, this is 0. 6 into minus 2 is minus 12. So, minus 6 into minus 12 is plus 72. Okay. Now, see here carefully. Now, if you see here in the table, the conditions which I gave, I write here one more time the conditions. The conditions were, if AC minus B square is greater than 0, AC minus B square greater than 0, and if A is lesser than 0, that point is what point? Maximum. And if AC minus B square greater than 0, and if A is greater than 0, that point is what point? Minimum. And if AC minus B square lesser than 0, we call it saddle point. That is, we don't, it is of no use. It is neither maximum minimum, so it don't get condition. Okay. Now, see here, greater than 0, this also greater than 0, so we only take those 2 points. But since this is lesser than 0, we don't take it. Why? These are what points? We call them saddle points. Right here, these are saddle. This also is, we don't take it. We only take which points? Greater than 0, greater than 0. And our condition, compulsory condition is AC minus B square should always be greater than 0. See. And if A is lesser than 0, that point is what point? Maximum. See here. Here is lesser than 0. So, this is what point? Maximum. For this point, the function will have maximum value. Why? Because AC minus B square greater than 0 and A is lesser than 0. And here AC minus B square greater than 0 and 6 is also greater than 0. So, this point is which point? Minimum point. So, this is a point 1, 2 for which the function will have the minimum value. So, the maximum value of this function f of xy occurs at minus 1, minus 2, what the conditions imply, and the minimum value of this function occurs at 1, 2, where the condition AC minus B square greater than 0 and A is greater than 0 implies. That's all. That is how we solve from the question table simply. So, let us find a maximum minimum value here. So, the question is f of xy equals x cube plus y cube minus 3x minus 12y plus 20. So, we have f maximum is at the point 1 minus 1 comma minus 2, minus 1 comma minus 2, that will be now in place of x put minus 1 and y put minus 2. So, this will become minus 1 minus 8 and plus 3 plus 24 plus 20. So, we get it as 28. Okay. And similarly, f minimum occurs at the point 1 comma 2. So, we have 1 plus 8 minus 3 minus 12 plus 20, correct. 12 to the, sorry, 24 plus 20, fine. So, my 1 plus 8 minus 3 minus 24, 20. So, get it as how much? 2. Therefore, f maximum is equal to 28 and F minimum is equal to 2. That is the final answer. These are the extreme values for the given question. That is it. Very, very simple. I hope you understood a clear cut procedure how to do it, but you need to practice this to get the answer perfectly correct and get a full marks. Okay. So that is all in today's video. I was able to solve one question step by step perfectly here, and you've seen that drawing the table and putting the values make it more and more easier to understand such problems, but it needs more and more practice. So I will be solving one more question, so please refer the next video for the other question. These questions are very, very important and they are asked in the VTU examination. So till then, keep practicing, be confident, happy learning, happy engineering. See you in the next video. Bye.